Okay, hello. You are opening up your OMG to page 54 so we can take our notes on the factoring of the difference of two perfect squares. Okay, page 54 of our OMG. First thing we're going to do, we've got two definitions we need to write. So first definition is what a difference is. So remember, a difference means it's an answer to a subtraction problem. Okay, and our second definition is perfect square. And what a perfect square is, it's made by multiplying two of the exact same integer or variable. So pause your video, write that stuff down. Okay, so let's list some perfect squares. So we find perfect squares by doing 1 times 1. So we're multiplying the number by itself. So 1 times 1 is 1. Okay, or 2 times 2, which gives us 4. So 4 is a perfect square. We could do 3 times 3, which is 9, 4 times 4, which is 16, 5 times 5, which is 25, 6 times 6, and I can go on forever. 36. These numbers go forever because numbers go forever. Okay? They can also be variables. So we could do like x times x, and the perfect square would be x squared. Or we could do variables with an exponent. So we could do like y to the third power times y to the third power. That would give us y to the sixth power. Or we could do numbers, integers, and variables. So I could do like 9v to the fourth times 9v to the fourth. As long as they're the same, 9 times 9 is 81. I have 4 V's and 4 V's, so that makes 8 V's. Okay, so all of these are perfect squares. There's no way to create a whole list because perfect squares go on forever, but this is a good list to get us started. All of these are called our squares. So all of these are called our squares. And right up here, this list up here is called the square roots. So square roots, or sometimes you'll see this symbol on your calculator. So our first example is factor 4x squared minus 25. First step is super duper important. It is GCF. Okay, and we're going to do GCF just like we did it before. Okay, so pause your videos, find the GCF of that. Okay, so I got 1 times 4, 2 times 2, x times x. And for 25, I got 1 times 25, 5 times 5. So if I'm looking at this, the biggest one that they share is a 1, and they don't have any variables in common. So the GCF is 1, which is the same as no GCF. So I don't need to do anything with my GCF this time. Okay, my second step is to decide if it's a difference. So up above, we said difference means subtraction. So I need to look at this to see if I've got a difference. And I do. So check, we're good with this step. Okay, step 3 is to see if we have two perfect squares. Two perfect squares. Okay, so if I'm looking at this, I've got 4x squared. So I'm asking myself, what number times itself makes 4x squared? So I definitely have a 4. That's on my list. That's 2 times 2. X squared is on my list. That's x times x. And 25 is on my list. That's 5 times 5. So I'm going to write down what it is. So 4x squared would be 2x times 2x. And 25 would be 5 times 5. So this is a check. We did it. Okay, next step. Step number 4 is to write the final answer. Okay, so to write the final answer for this, what we do 2 parentheses, double parentheses like we always have. We put 1, 2x in the front of each of them. And then I bet you can guess what we do with the other ones. The 5 goes at the back. Okay, and then it's always a plus and a minus. It's always a plus and a minus. So our next step is to do the square root of the two perfect squares, and we put them inside the parentheses, one with a plus and one with a minus. And then we would always write the GCF out front. If we had a GCF other than 1, it would go right here. Okay, but that is our final answer. The reason why this works is because what we're making is negative 25 here. And in order to make a negative 25, we use a positive 5 and a negative 5. Okay, and when we're multiplying this, the distributive property, 2x times 2x, we would get 4x squared. Here we would do 2x times negative 5, which would give us negative 10x. 5 times 2x, which would give us positive 10x, and that would cancel out. And then 5 times negative 5, which is negative 25. Okay, let's see if we can do this now. We're going to use our steps. Our steps, first we find the GCF. So GCF for this one. Okay, so I already started doing the GCF for this one. I listed my factors for 3y squared. Now, I know the only number that goes into 3 is 1 and 3, so I could just check to see if 48 is divisible by 3. I definitely know it's divisible by 1 and 48. But then if I do 48 divided by 3, I get 3 and 16. I don't need to list them all. That's all I need to see that the GCF is 3. And that 48 doesn't have any variables, so my GCF this time is just 3. Now, since I actually have a GCF, I need to divide it out this time. So I'm going to divide by 3, divide by 3. 3y squared divided by 3 gives me a 1y squared. And 48 divided by 3 gives me 16. Okay, so I'm done with this first part. Remember, I can think about with the GCF out front if I want, but I don't really need to focus on that because that's just going to come along for the ride. The next thing I got to see is this a difference. I always ask myself, do I get a difference problem? Okay, and I'm looking for a minus. Hey, I got that minus, so that's good. Okay, next thing, are they perfect squares? So I'm looking for 2 squares. So if I look at 1y squared, does a number times itself give us 1y squared? Well, I know y squared is y times y, and 1 is 1 times 1, so I could do 1y times 1y. And 16, hey, doesn't 4 times 4 make 16? So yes, 2 perfect squares. My answer was yes, so I keep going. Now this is where I'm ready to write my final answer. I do my 2 parentheses, one with a plus, one with a minus, and I shove that stuff in it. So I've got my 2 parentheses, one with plus, one with minus. I got 1y in the front of each one and 4 in the back of each one. And I don't want to forget my original GCF. That is the final answer. Okay. So if you ran out of space on page 54, you can go to page 55. You don't have to, but you can. We're going to keep going. So step 1, just like always. Actually, you know what? Pause, write down your steps right now next to your problem. You should know these steps now. Okay, so GCF first. If I'm writing my factors, I can remember that there's an invisible 1 there. So I know that this is 1x, which is just 1 times 1 and an x. For 36, a squared x, the only number I can pull out of a 1 is a 1, so I know it's going to be 1 times 36. And then I got to look at the variables. I got a times x, and they both have an x. So my GCF is 1x this time. So if I divide by 1x, okay, so I can never get 0. When I do 1x divided by 1x, it's not going to be 0. 1 divided by 1 gives me 1, and x cancel each other out. So there's just a 1 there. Now 36 divided by 1 gives me 36. And here I have x squared, or a squared x, and an x that I'm getting rid of. So I'm just going to get rid of that x, and I have an a squared here. Okay? Now I need to see, is it a difference problem? So I look to see if there's subtraction. Yes, there is. So I keep going. Next, I need to look, are they perfect squares? So does a number times itself make 1? I hope you're shouting yes. 1 times 1 makes 1. Okay? And then 36a squared. So if you don't know, just test them. 1 times 1, 2 times 2, 3 times 3. And to make 36, that is 6 times 6. But we need this a with it, so it's going to be 6a and 6a. So check. Okay, and then finally, number 4 is to write my final answer with my plus and my minus. So I end up with 1 and 1 in the front, and 6a and 6a in the back. And don't forget the original GCF, the 1x. Okay, and I could always, if I want, make this 1 invisible. So it would just be x times the quantity 1 plus 6a times the quantity 1 minus 6a. Okay, if you're out of space on 54, go to 55. So our steps, go ahead, write them down so we could talk through them. Okay, so GCF is first, just like always. So we've got 100 W squared, and we've got 25. I hope you always start with a smaller number because it's easier. To make 25, we can only do 1 times 25. Come on, 1 times 25, and 5 times 5. And then we ask ourselves, well, the biggest number here is 25. I wonder if a 25 can go into 100. Let's see. 100 divided by 25, that gives me 4. Yes, it does. Okay, and then I got W. And this one has no W. So the GCF is just 25. I'm going to divide it out. 25. Okay, remember I always put that GCF out front. Okay. And I got 100 divided by 25 gave me 4 W squared plus 1. 25 divided by 25 is 1. Okay, next up. Do I have a difference? OMG. No, I don't. I don't have a difference. So that means that we have to stop. We are done doing this problem. I can't draw a stop sign. Stop right here. Anytime we have a plus, not a minus, we have to stop. This is the final factored form. There's nothing else we could do here because this is a plus, not a minus. So if it is not a difference, we can't factor any further other than only the GCF. Okay, last problem, problem 5. So do your steps, find your GCF for me before I do anything else. Okay, so I listed out my factors, and it looks like the biggest one they have in common is a 1, but they both do have an F. So it's a 1F I'm going to take out. So if I divide out a 1F, I end up with 1F on the outside, and then I have 10, and this one had 2 F's, and I'm dividing by 1F, so there is an F left here. And then here I've got 49 divided by 1, which is just 49. Okay, and the F cancel out. Okay, so next up it says, is there a difference? Okay, this is where we got stuck on the last one. Let's see, is there a difference? Hey, yep, it's a difference. Check, keep going. Are these 2 squares? Well, does a number times itself make 10 an integer? No, because 3 times 3 makes 9, right? 3 times 3 makes 9, and then 4 times 4 makes 16. Okay, so that's not a perfect square. So guess what? Stop. There's nothing we can do for this. If we can't go and have 2 perfect squares, we can't do this problem. That's the final answer. Okay? A dead giveaway here is that F had no exponent. It is not a perfect square if there's not an exponent on it. Okay? Now you are going to be working on your notes. Now you're going to be working on your practice, okay? So make sure you have all these notes on 54, 55 so that you can get the practice done.